Hello friends, welcome back to the channel. Today I will talk about the functional verifications. So functional verification is something which is very preliminary but very solid things in the VLSI design and VLSI circuit analysis. So when we called about functional verification, the other word that comes to our mind is basically the simulation. Now what is simulation? Simulation is not necessarily a VLSI term. It is quite common to the normal any pupil. So when we call about simulate, for example, take about a example that you are just playing a car racing game. So what you will do, you will have a joystick in the form of a steering and you just drive the car, and you do not have the actual car instrument, or actually you are not sitting inside the car, but still you are enjoying the car driving or car racing. So similarly, in the VLSI chip also, instead of actually manufacturing the chip, you can be able to check the chip functionality with the help of simulation. Now simulation is basically the other part, the other side of the software interface to the VLSI circuit. So when we call about simulation software, it's basically come automatically in the form of electronic design automation. Now electronic design automation has the ability to check the VLSI design with its software, different kind of software, before actually it is being manufactured or fabricated in the fab. Now coming back to simulation, when we talk about simulation, there are two types of simulation that comes to our mind. One is basically the digital simulation, another is basically the analog simulation. So when we talk about digital simulation, what comes to our mind is basically the different VLSI design in the form of gates. So the gates, for example, you might be knowing already that AND gate, OR gate, these are the combinational gate, and there are sequential gate also, like flip-flop and latches. So all these things consist of the gates, and digital simulation is basically just to check the functionality of this gate constructing for a particular circuit. Now there are analog simulation. In analog simulation, there are resistor, there are capacitor that consist of a particular circuit, and you can simulate those kind of circuit as well. For a particular design, there can be a mix of analog design and there can be a mix of digital design. So this is called mixed design, I would say. And in EDA software things, you can have a digital simulator, you can have an analog simulator. But today's discussion I will mostly do based on the digital simulation because it is very easy to understand. So in digital simulation, I'm just going a little deeper on the digital simulation side of the things. I hope it becomes more, you can connect more with that. In digital simulation, there are DUTs, design under test, which is basically your block, your circuit, your chip. Now you have to verify this with the help of simulation software. For that, you will require a test bench. Test bench is another block which works as an interface to the VLSI design. So it connects with the input and it connects with the output. So for example, take a example for a design. You have a AND gate. So your AND gate has a 2 input and 1 output. We just connect both of the input of the AND gate with some voltage supply, say for example 5 volt, and we will connect the output with the kind of LED bulb. You can instantly see the LED bulb is going. It basically lighting when we connect both the 5 volt to the AND gate. So does that mean that your circuit is behaving correctly? No. You need to check all the combinations of the input and see whether the output is expected or not. Now what you will do, you will connect one of the input pin with the voltage supply and other input pin with the ground supply. Then you will see that the LED bulb is not glowing. That means it is expected. AND gate circuit, for AND gate circuit it is expected. Now you will check both the input you will connect with one of the input is basically connected to the board, your light should not glow. Now both the input you connect to the ground, the light still does not glow. That means now you can say that your circuit is behaving correctly. But this is only possible for a very small circuit. You cannot do for a whole design when you have millions of gates for a particular design. You will have a ASIC. You can have a SoC, system on chip, where you can have multiple ASIC inside the SoC. It is not possible to check it manually. What you will do, you will require a simulation software, and also you will require a test bench. Now let's talk about what is test bench. Test bench is basically something, a digital block, where you will declare some input signal for every DUT input signal, for every DUT output signal. You need to declare those signals in the test bench. The next sub block of the test bench will have the random input generator. Mostly the random input generator are being used in the test bench to drive the signals towards the DUT, the design under test, your actual chip. Then another sub block is basically captures your output, and that basically the output signal that is being generated from your DUT, and it dumps to a particular file. We call it as a goal file. And last but not the least, the final signal. After a certain while you need to stop your simulation, otherwise your simulation continues forever. So you need to stop, maybe probably about after 1000 nanoseconds or any time you need to stop it with the help of a finish instruction. Now your output goal file has been generated. You need to verify that, and if you find this is correct, for every input signal combinations your output is giving correct, then you can say your chip is behaving correctly, at least in the design stages. So now what you can do is basically you move on in the chip design flow. So maybe if you are in the behavioral side of the design, or you can, after the synthesis, you are checking. So in two ways simulation becomes effective. The first thing is basically you can check at the behavioral level, Verilog level or VSTL level. The second thing is basically you can check in the synthesized netlist. So simulation is another way by which you can check that synthesis simulation, there is no synthesis simulation mismatches. That means your synthesis output is behaving correctly as it was before the synthesis. That's the behavioral level. So I think it makes some sense for you to understand conceptually, even if you do not have a very depth in the VLSI circuit or Verilog or VSTL, but it becomes meaningful to understand this at least at the conceptual level. So I will try to provide more details of the test bench, how it looks like, how the Verilog and VSTL construct are embedded in the test bench. I will also talk about the DUT, how does it look like, different kind of design, sequential and conventional, in my next video. So I will try to do that. So I think that's it for today's video. Before concluding, I would like to mention that I have recently published a book called Semiconductor for All, and this is a very basic book for semiconductor knowledge and understanding. Even if anybody does not have a good VLSI background, or a new entrant to the VLSI design, fresher, or any common people who are interested about knowing semiconductor, this book has 25 fascinating tales about semiconductor design. So you can consider buying this book. I will provide the Amazon link in the description section of the video. Another book that I have published recently, that is called The Global Chipware. This book is basically caters about the global competition that is happening across different countries, across different continents. It's Europe, Asia, America, and all these places around, across different continents, across different companies as well. So it is very interesting story, I would say. You can consider buying this book as well. I will provide the Amazon link also for this book in the description section of the video. I think that's it for today. Wait for my next video to come. Till then, Subhasish Chakraborti signing off.